I'm going to be talking about inverse trigonometric functions, and it's going to be a little bit confusing from time to time on how to sort all this out. But I think you'll see kind of the whole point of this is to make sure that we're able to go both directions when it comes to dealing with trig ratios. So what I mean by that is, I'm going to be spending a lot of weeks making sure you guys can do the sine of 30 degrees. But if I ask you, if I know that the sine of some angle is 1/2, can you tell me that that angle is 30 degrees? So kind of just going backwards when you think about this idea of inverse, okay? So let's start off by looking at a few of these examples, all right, of trig functions. And as I mentioned, the first one, even though it's radians, is what I was just talking about, right? You essentially at this point should have this memorized. And so I need you to go the other way by saying the arc sine, or the inverse of the sine function of 1/2, is the same as pi over 6. So you can use sine to the negative first power. You can use inverse of sine. I'm going to be using arc sine to say the inverse, but the idea is the same, that we're just going backwards. I give you the trig ratio, and you need to tell me what the angle would be. Okay, so this idea of inverses is going to be important in terms of helping us solve trigonometric equations going forward in the next unit. All right. So this idea of an inverse function is f to the negative first power of b would be equal to a. Now, this was important back when we did this in algebra, having one-to-one functions. But you'll notice, if you think back to the first lesson of this unit when we graphed sine, cosine, and tangent, that we really, they're not one-to-one functions. So what we do to kind of get around this is we restrict the domain of each function to certain x values, and that will allow us to focus on a one-to-one function. Okay? So let me give you this example here. So this is the sine of theta restricted from negative 1/2 to positive 1/2. So that is a one-to-one function. Okay, it passes the vertical line test and the horizontal line test. This is the cosine of theta. It's actually the very beginning of it, from 0 to pi. And again, that is a one-to-one function. And this last one is the tangent of theta. And the only thing you need to know about this restricted domain is that it doesn't include brackets. Because if you remember from when we graphed this a few lessons ago, right, we have asymptotes at pi over 2 and negative pi over 2. So that's why you'll notice the other two have brackets, but for tangent, that restricted domain has parentheses. Okay, so here's kind of the basics of these inverse trig functions, right? That idea of arc sine function has this restricted domain, and then when we do the inverse of that, obviously you can see that it becomes the range. Same with cosine and same with tangent. So the key takeaway here on this first page is we can do inverse trig functions, but we just have to restrict the domain and range. Okay, so when we look at this next page, all right, we are going to switch the domain and range of the original functions. You can see it's a little bit easier on mine because I have the different colors, but you can see what we talked about, limiting the sine of x on the previous slide, and then that arc sine function, right, the inverse, is going reflective about that line y equals x. And that's something that we kind of talked about, or you definitely talked about in Algebra 2, and we hit on this again when we talked about exponential and logarithmic functions in the first semester. Those are inverses of each other, and they are reflective about this line, y equals x. So here's cosine, and then there's tangent, okay? So these are the kind of the basics what we'll be doing for these inverse trig functions. All right, so let's do a quick example, or two of them, I should say. All right, so we'll start with this first one. It says, given that the sine of pi over 12 is approximately 0.96593. Again, I don't expect you to know this one. This is not one of our special ones. All right, write a relation involving the inverse sine. Okay, so I'm going to use arc sine or inverse sine. So sine to the negative first power of my ratio, 0.96593, is equal to 5 pi over 12. So like I said, we're going to be essentially, we know the ratio, we're going to be solving for the angle as opposed to the other way around, where you knew the angle, trying to find the trig ratio. Let's do another one with cosine. All right. So the cosine of 0.5 is approximately 0.8776. So if I have cosine to the negative first power of my ratio, right? So always think, what is my trig ratio? It's this decimal, and that's equal to 0.5. All right, so just kind of some basics for the notation that goes with this. Now, for these next ones, these are the ones that I need you to be ready to do, and you'll have the Edpuzzle questions coming on this. Also, the IXL link with this lesson is going to help you practice. And this is the stuff I need you to be ready to do before we get into solving trig equations. So I'm going to do number one here, a little bit more space. It's the arc sine of 1/2. All right, it doesn't say degrees or radians, and so I always assume, and I tell you to do the same thing, if it doesn't say what the unit is, I'm going to use radians. So this one, I think, right, you should have that table memorized from our special angles quizzes in the first unit, right, in January. So in this case, if I'm asking, so if I want to go backwards, I know the sine of some angle is 1/2. What is that angle? That angle is pi over 6, or 30 degrees. All right, let's do the same thing. The sine to the negative first power of negative square root of 2 over 2. Now, be careful here. It's telling us that our trig ratio is negative, so I'm no longer in the first quadrant. So what I tell students is, when you're dealing with this, right, we have to think about our restricted domain here. All right, if I go up to my restricted domain, for sine, I'm thinking this negative pi over 2 to pi over 2. So just write this here. All right, so thinking negative pi over 2 to positive pi over 2. All right, so right, when I have to answer this question, first off, my brain is going to the table, and so I'm thinking pi over 4. But the sine of pi over 4 is positive square root of 2 over 2, so that's not going to be the answer. So I need to find something in between negative pi over 2 and pi over 2, which is quadrant 1 or quadrant 4. I just said quadrant 1, pi over 4 doesn't work, so the angle that's in quadrant 4 that would work in between negative pi over 2 and pi over 2 is negative pi over 4. All right, let's do number 3. We've got cosine. Same idea here. I'm thinking about my special angle, so my table. The cosine of, let's see, this is going to be a cosine of pi over 6 is the square root of 3 over 2. All right, so I'm thinking, what is my restriction for cosine? And that's from 0 to pi. All right. And so from 0 to pi, if I want to have a negative ratio, right, all students take classes, I need to be in the second quadrant. All right, so if I need to have a reference angle of pi over 6, all right, we'll do a quick little sketch here, right? I need to be in the second quadrant. So here's my angle, and I said the reference angle has to be pi over 6 to make this work. So reference angle is pi over 6. I got to back up from pi. So pi minus pi over 6 is going to be 5 pi over 6. That's probably the most confusing one so far. So again, you'll have some good practice on that with the IXL link. All right, tangent to the negative first power of 1. Using my restriction here for tangent, that's going to be negative pi over 2 to pi over 2. So it's just like sine, but you don't include the pi over 2s. Those are asymptotes. All right, so tangent of some special angle, which is 1, that's going to be 45 degrees, or pi over 4. And pi over 4 is actually in that interval, so it just is pi over 4. Okay, let's try some other ones. Very similar. So this one, number 1, arc sine of negative 1. This is going to be quadrantals here. So make sure, right, if you don't have this written down somewhere or a photo of it, make sure you've got your quadrantals somewhere because you're going to need these to be successful in this class. And this is 2 pi. All right, so the ordered pair is 1, 0. We've got 0, 1, negative 1, 0. 0, negative 1. Don't forget, when you do this quadrantals, we're always thinking cosine is in the x, sine is in the y. Okay, so this first one. Remember, I'm going in between negative pi over 2 and pi over 2 for arc sine, and I'm looking for a y value of negative 1. So from negative pi over 2, I guess I can put that down here, right? Here's negative pi over 2. All right, a y value of -1 is actually going to be negative pi over 2. And because it has that bracket right here, right, it's included, so I can actually use negative pi over 2 as an answer. Okay, number 2, arctangent of -1. This one is actually not a quadrantal, right? The tangent of pi over 4 is 1. So I know it has something to do with pi over 4, but for tangent, I'm in the first or the fourth quadrant, right, between negative pi over 2 and pi over 2. So I just need to move to the negative here. Negative pi over 4 would give me that -1. Okay. Number 3, arc cosine of -1. I'm going to do quadrantals here. Between 0 and pi, and actually pi over here has a cosine of -1, so it's going to be just pi. And my last one, arc cosine of 1/2. This one is another special angle, not a quadrantal. The cosine of pi over 3 is 1/2. All right, and since it's positive 1/2 between 0 and pi, pi over 3 is the answer. All right, so again, I think you'll get some good practice with this, but it's just about getting your brain to realize we're going backwards. Okay, let's do some of this with some triangles, some right triangles. All right, so it says to solve for angle theta using this idea of inverse trig functions. So what I notice is I'm looking for theta. I have the hypotenuse, right? This is my hypotenuse across from the right triangle, or excuse me, the right angle. And this is the adjacent side when it comes to that angle theta. So if I'm using my SOHCAHTOA for adjacent and hypotenuse, I'm going to use cosine. So cosine of theta is adjacent over hypotenuse. So let's plug in what we know. We don't know theta yet. We know adjacent is 9. Hypotenuse is 12. So what I'm going to write, my mathematics I'm going to write is arc cosine. So if I go backwards from this trig ratio, I should get my angle theta. And this is where I'm going to encourage you to go into using your Desmos calculator. Again, doesn't say degrees, so I'm just going to assume radians is okay. I'm not that concerned if you do this in degrees, but I always tell students if it doesn't say degrees, I'm not doing degrees. So let's go to Desmos. Let's do our check to make sure that we are in fact in radians. So click the wrench when you get there. All right, so here's my wrench, and I am in radians. Excellent. So I'm doing arc cosine, so cosine to the negative first power of, I believe it was 9/12. Yes, 9/12. That fraction of 9/12. And if you want to reduce it, you can, it doesn't matter. So as radians, this angle theta is 0.7. You know what? I just realized they probably want degrees since we're dealing with this right angle here. So I'll go ahead and change it to degrees, but it doesn't really matter. All right, which is approximately 41.4 degrees. So 41.4 degrees. Doesn't say how to round, so I'm going to go with that. Let's do another one. I've got my hypotenuse again for this triangle, but this time I've got the opposite side from that angle theta. So with SOHCAHTOA, that's going to be sine of theta equals opposite over hypotenuse. So I'm going to do sine of theta equals 6/10. Again, you can reduce if you want. So going into my calculator, I'm going to do arc sine of 6/10 since I know the ratio, and it will spit out that angle theta. So let's do the arc sine of 6/10 to find what this angle is in degrees. All right, so arc sine, sine to the first power of 6/10. It is approximately 36.9 degrees. 36.9 degrees. All right, so that's one way we'll be using Desmos to help us with these inverse trig functions. Okay, so now some composition. I know it's been a while since we've done composition, but the idea here is that if you compose inverses, you will get x. If you remember your days in Algebra 2 when you did f of g of x equals x, and then g of f of x equals x. If you found this to be true, that f of x and g of x were inverses of each other. So it's just going based on that. We know that sine and arc sine are inverses of each other. So if we compose them, we will get x every time. So you notice this column here has all x's. The key thing is that depending on the order in which you do this, right? So if your arc sine is the inside of your function, or if the sine is your regular function, it changes what your restrictions are. So make sure just to notice the order in which you are doing the composition that will impact what restrictions on the domain are happening. So just keep that in mind. Refer to this if you need to. Okay, so let's try this first one. It says evaluate. Do it over here. Actually, no, I'm going to put sine. This, if you notice, I have sine of x is in the parentheses. So if I go to my table, since the sine of x is in the parentheses, that actually is that same restriction we used before, negative pi over 2 to pi over 2. So for this one, all right, it's going to just be pi over 3 is the answer because pi over 3 is within that restriction. Let's do the next one. All right, the next one is the same thing, but it says 2 pi over 3. Unfortunately, 2 pi over 3 is not in between negative pi over 2 or pi over 2. So I need to find an answer that's going to be within those. So let's just sketch for a second 2 pi over 3, which is in the second quadrant. So here is 2 pi over 3. Finding the reference angle, as I told you, if it's 3, 4, or 6, it will just be the reference angle is pi over 3. All right. And just to make sure we're talking about this same thing for, the same restriction here, when we look at this, we're going to have our answer just needs to be between negative pi over 2 and pi over 2, which will also be pi over 3. Okay. Let's do the next one. Now, the next one is cosine. So let's just do a little work here for cosine. So cosine, it's the negative first power of, cosine of x is going to have the restriction 0 to pi. Confirm with the table if you need to right here. Yes, 0 to pi. All right, so when it says, what is the answer here? Is 2 pi over 3 between 0 and pi? We just said that 2 pi over 3 is in the second quadrant, so it's not past pi. So actually the answer here is 2 pi over 3. All right, now the last one. The last one you can very much see is not between 0 and pi. It's a negative. So when I sketch that one, let's sketch negative pi over 3, right? Moving clockwise. There's negative pi over 3. All right. The reference angle is pi over 3, right? That distance back. The reference angle is pi over 3. And is pi over 3 between 0 and pi? And the answer is yes, it is. So the answer for this last one is pi over 3. All right. So again, it's just really all about the restriction. Let's try these last two and then we'll be done. So tangent, where your composition which has tangent in the second part is going to be between negative pi over 2 and pi over 2 like we did before. So tangent to the negative first power of tangent of x. The restriction is negative pi over 2 to pi over 2. Remember, not included. All right, so is pi over 8 between negative pi over 2 and pi over 2? The answer is yes. So this first one is just going to be pi over 8. All right, and then the second one is not, right? For the second one, you'll notice that 11 pi over 9 is not between negative pi over 2 and pi over 2. So if we do this quick sketch here, that is actually past 1 pi, right? Because 1 pi would be 9 pi over 9. So it goes past pi. And so to find the reference angle, I need to back up to pi, right? This is pi. So if I subtract 11 pi over 9 minus pi, which is 9 pi over 9, I get a reference angle of 2 pi over 9. All right, and it is 2 pi over 9 between negative pi over 2 and pi over 2. The answer is yes. So the answer is 2 pi over 9. All right, and that's it. So hopefully you have a chance to practice. Go to the IXL link and make sure your brain understands how we're going backwards to find angles. Good luck.